Hello and welcome back to the dungeon, or welcome to the dungeon. I just want to show you a little trick that I discovered the other day, and as far as I can tell, it's not been documented before, so I thought I'd tell you all about it. It could come in handy if you ever had any free space on the bench. Fuses. Common problem, fuse blown. Which fuse is good? And these ones are glass fuses, you can look inside them, but normally you get out your meter. Say you're in a pickle, you're out in a situation where you don't have your meter. Capacitive touchscreen, everyone's got one in their pockets. Here's a fuse. The fuse works. There's another fuse. I happen to know that I whacked 30 amps through this and got a nice blue flash, so no, this fuse is dead as a dodo. This one works like a stylus. What's going on? Well, of course, this is just shorting me out to the screen. I'm setting up a capacitance with the screen. So, capacitive touch screens. Need a pen. Need a pen desperately. This one should work. Capacitive touch screens, magic things, ubiquitous these days. We have a screen. We have some magic black box circuitry. And then we have the glass on top of there. Yeah, bad drawing, whatever. And what we do is the screen applies some high frequency charge to to either a film or a network of wires, something like that, on the screen. Technologies vary. The glass dielectric acts as the center part of a capacitor, and then when you touch the other side, you form the other side of a capacitor. You pass this high frequency high frequency current, and you either pass it via a resistance to ground, or if you're not grounded at all, you're still going to pass current because you're going to be passing this, like an antenna does, into the ether. So basically what we've got is one half the touchscreen as one half the capacitor, glass dielectric in the middle, the other half of the capacitor is you. Obviously, a capacitor is going to pass some high frequency current, and that's the detection. Black box circuitry does all kinds of clever stuff down here to detect the position. Sometimes it's charging from different points on the screen, all kinds of clever stuff. So what are the limitations with using this as a fuse tester? Well, you can't just use it as a continuity tester because what's going on this side of the capacitor is really important. If it's just you touching the screen, which is what it's designed for, you get a certain capacitance from the screen to you, with the glass dielectric down the middle. If you try to use this as a continuity tester, essentially putting a resistance in here. So if you try to get a big complex thing, maybe a big hunk of wire, you've got two possible problems. Either you get one half of the capacitor formed, and the other half of the capacitor is going to be formed by your piece of wire radiating high frequency current into the ether before you even get to the circuit you're trying to test. Or you're going to have too much resistance in here, and you're not even going to form an effective capacitance at all. So that's the limitation. But you need to buy a fuse tester. Turns out you've been carrying a fuse tester around in your pocket. Let's just verify those fuses. Make sure that actually I'm not talking rubbish and that this works. Hopefully you can see the meter there. Fuses. Like I say, if you've got a meter kicking around, you don't need this little trick. But if you don't have a meter kicking around, what's that? A few hundred kiloohms. And then that one, that's probably me actually, I was holding that. Put it down on the mat and try it again. Yeah, outright overload. And this one, let's do it on the mat. Again, there we go, 0.3, 0.4 ohms. Don't trust these meters down at that range anyway. But there you go, neat little trick. Carrying a fuse tester in your pocket. Don't buy a fuse tester.